is the value of the current, and that is the answer to Roman figure 1. Please, you can show the analysis again, show the steps again. So now let's go to Roman figure 2. The voltage across only the inductor, not voltage across the circuit. So if it is the voltage across the inductor, I can say voltage in the inductor according to Ohm's law equals to current in the inductor and then inductive reactance. So this one starts as the resistor because in Ohm's law I have V equals to IR. So the voltage I'm talking about now is the voltage in the inductor. The current I'll be using was the current in the inductor, and then the resistance must be the inductive reactance. So we are using this formula now. So the voltage across the inductor is equal to current across the inductor. I told you that current will remain constant since it is series. So each of them have equal amount of current. So which way the current you have brought in here is what you are using. So I'm having 0.0088 times, and I've calculated this inductive reactance. Our inductive reactance is 1571. So voltage across the inductor is equal to, please multiply these two values for us.
18.95 volts.
13.95 volts. That is the voltage across the inductor. Please study that analysis again. Are you done?
Yes, sir.
Study that analysis again. So let's go for Roman figure 3 now. Roman figure 3. The phase angle between the current and the applied voltage. So this is the formula for finding the voltage. So this is Roman figure 2, Roman figure 3. So the phase angle is given the formula of tan theta equals to inductive reactance over resistance. Please watch out for that. The phase angle between current and applied voltage is most of the time, don't let me say always, it is most of the time the inductive reactance divided by what? The resistance. And we have calculated for inductive reactance. That is 1571. This is inductive reactance over, and we have resistor or resistance to be what? 600. So our tan theta is equal to, please divide this one. I have 2.62. Now I am looking for angle. Angle is what you have. So theta is equal to tan inverse of 2.62, and that is what?
69.1.
So 69 degree, 69.1 degree, which can be approximated to what? 69. So I am done with this now. So we can go for Roman figure 4 now. Roman figure 4. What says Roman figure 4? The average power supply. Whether they use the word average or not, power is always, so power in physics is I square R or IV. This IV too is also derived from I square R because V itself in the physics is IR. So V is equal to IR. This is not part of the solution. I just want to let you know that the two of them are the same thing. So V is equal to what? IR. So by the time you put V here now, I'll be having power is equal to I dot what? R. And that is I times R, I square R. That is how they call this. Okay, so power now. Let's go to our current will remain the same since they are in series. So power is equal to what's our current? 0.00888 all square. Then times our resistor is what? 600. Please get the square of this for me. Get the square of this. 0.000. Be fast. 40.
Yes, 7885.
7885. Then times what? 600. Okay. What's the value?
0.
So our power is equal to
0.0473.
0.0473 watts. We can approximate this one to standard form if you like. It become 4.7 times 10 raised to power minus 2. So we move this in 2 times. So 4.7 times 10 raised to power minus 2. So the very last question now. Potential difference across the what? Resistance. Just follow the format. Potential. This one is potential difference across the what? Inductor. So here, potential difference across the resistor become VR, because potential in the resistor, that's what you are calculating for, equals to current in the resistor, Ohm's law, then resistor what? Itself. So the potential difference upon the resistor is equals to current in the resistance or in the resistor is also equals to what? 0.00888. Because I've told you, since they are all in series, they all have equal what? Current. So I can be having 0.00888. 0.00888. That is supposed to be 3. Okay? Then times what's our resistor? 600. 600. Include one more 8 here and let's see what happens. Confirm it. You can do that later. We have multiplied this. So 0.00888 times 600.
5.328.
5.328.
328.
And this can be what? Voltage. We are looking for voltage. So it should be what? Volt. Okay, please confirm this by using the 0.00888. Let's add that 8 in 3 10 times this and see the value still remain the same.
13.9.
Okay, it means there is 8 missing here, please. So that is the end. The first question, look at it for the steps. The second one, this is the answer. The third one, this is the answer. The fourth one, this is the answer. And the very last one, this is the answer. So what you are going to do for me is that I will read this question for you, or you look at it yourself so that you can solve it out. A coil of incident, a coil of inductance, a coil of inductance 0.007 Henry, a resistor of resistance 8 ohms, and a capacitor. This one now has the 3 of them as regulators. So resistor is there, inductor is there, capacitor is there. So this value for capacitor 0.001 farad are connected in series. Series means all of them must have equal amount of current to an AC source of frequency. This frequency at 500 over pi. Now if RMS voltage across the coil is 3, across the resistor is this, and across the capacitor is this, and across the resistor, this is for resistor, this is for capacitor, and this is for inductor. Let's take it again. RMS voltage across the coil, the resistor, the capacitor, and the third one, that one is missing. Oh, please check from past question. Did they give only 2 of them?
Yes, it's only 2 of them. Yes, it's
They mentioned only resistor and capacitor.
Yes, that's
And
right.
now look at this. Do they repeat these 3?
Yes.
Eh?
Yes.
Let me have it. This one is the combined. This one is for resistor, and this one is for the way we mention it. So the first one, inductance is the first one. Then capacitance. This one is for what? Capacitor. Why this one is a combined? So let's go back. If the RMS voltage across the coil, across the resistor, across the capacitor, this one is for the coil, this one is for the resistor, this one is for the capacitor. It's only a inductor that was not given a voltage. Okay? Now draw a vector diagram to illustrate the voltage. Forget about this if they cannot handle that, but they can try it. Now calculate the RMS voltage of the what? Of the source. RMS current in the what? Circuit. The power dissipated in the what? Circuit. Just power. Then write down so leave this one now. So what you are doing for me, calculate RMS voltage of the source. The RMS voltage of the whole source now. Then RMS current in the circuit. May combine current, then power. So you can try this, and try this. So the remaining one, any comment you have, so you can send us your comment so that we for you in that comment. Thank you. We will meet in the next class.